For this tutorial, we're going to talk about a concept called magic numbers. This is, just look on the schedule, go to tutorials, magic numbers. Now, the idea of magic numbers is that if you went through the lecture material and ran some of the code, you'll notice for one of the versions of the Mario program that we capped the pyramid at 23 steps high. And we set that number so the pyramid didn't get ridiculous, and it's just a practical thing we set. But we want to think about setting constants like that in our programs. So, what does 23 mean if we plop it in to a loop in a program? Is it obvious? We need to think about, remember, writing constants into our code for that future person, including our future self who might see it. Well, here's an example where we have a loop that's doing something, and maybe we're going to deal some cards, and maybe we have a deck of cards that's got some name, and maybe we're going to do a for loop, and a standard deck of playing cards has 52 cards in it. So maybe we set the number of cards that we deal, and we iteratively deal the cards through some code that might be included here up to 52. Now, this would be an example of a magic number. We've just plopped this number, we've plucked it out of the air, we've put it there. But what's the potential problem? What's the potential problem? What if we wanted to change the deck? Maybe we wanted to change the number of cards in the deck, or maybe we wanted to account for some extra cards like jokers or something like that. Well, one problem is that if we had the 52 limit appearing multiple places in a program, especially if it was a big program, we'd have to find every little place and replace every one. And that's just a pain. It's bad practice. So what we could do is we could initialize the value of an integer and a variable name, we call deck size. We could initialize that to 52. This introduces another problem, though. What if deck size gets modified somewhere else in the program? We are thinking about magic numbers that are numbers we want to define, and we want to protect the value that those numbers take. That's what we're talking about when we're talking about magic numbers. Well, there's a method to do that in C. In fact, a lot of languages have something like this, and we use the define statement to define a variable with some sort of value. Okay, and the technical name for this process of defining a variable like this is a preprocessor directive. So this searches through the whole program that you've written, and it replaces the name with that replacement value everywhere it's mentioned. And we do it with this defined constant right at the top of our program. So at the time that it's compiled, it makes all of those changes for us. For example, let's say that we want to define our own version of pi. Why would we do that? Well, we might want to define it to an adequate precision that we need for our calculations. We define that, and every time that you mention capital P, capital I, the value you've defined in your program, it replaces it with the float value that you've defined like that. Same thing, we could do it for a character string. Define course as SQ4007. It would go through the program, define every time you've mentioned the all caps course. It's by convention that we would use all caps for a preprocessor directive like this when we're defining a variable value. That's just a convention in the code. So here, what we might do is we would define our deck size variable to the integer 52. We'd write our function out with cards and deck name, and use that deck size variable in our for loop. And, then, whereas on this slide, we've got the deck size set to 52, and it goes through and replaces deck size everywhere in our program with 52. If If I just click the next slide, what if we wanted to change it to 32? Well, then no problem. The rest of our code doesn't change. This is the easiest way to do it. And, we could change it to a much bigger number, and we could do that over and over. This is a very powerful concept in programming. It's very simple to do, thankfully. And that's all I have to say about that.